This is the last nearpod for dilations on the coordinate plane, and we're just looking at solving a few problems. This one should go by pretty quick. This one is in your notes. Right, it's kind of at the bottom of the third page. So triangle JLM has been dilated by a scale factor of, right, so to find the scale factor, and you have all the words in there, right, so for finding the scale factor, use vertical and horizontal distances, right, vertical and horizontal corresponding lines whenever possible, right? Otherwise, you have to use the distance formula, right? It would be a lot easier, right, if you use horizontal and vertical lines, right? And when you're finding scale factor, remember it's image over original, right? So now a really good one to use in this problem would be one of two things. Either the base there, mj and m prime j prime, or the altitude. Let's see, because both of those would be horizontal or vertical. Let's see what we get for each one of those. All right, so let's start with m prime, j prime, and mj. All right, so m prime, j prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let me just double check. Yep, from -6 to 6, right, that would be 12. All right, so this distance here is 12. You can write that in. How about mj? All right, so 1, 2, 3, 4. So mj was 4. 12 divided by 4 reduces to 3. Let's check with another vertical horizontal line, in this case a vertical line, and that would be the altitude. All right, so the altitude for the larger triangle here for the image would be 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so it's going from -3 to 6. That's 9. The image of the, the altitude of the pre-image, right, of the original here, right, it's going from -1 to 2, 1, 2, 3. And again, we get 3, and we should get the same answer. If we don't, then we should check our work. All right, so just compare image measure to original measure and use vertical and horizontal lines. All right. That's all there is to this one. I only did one example. So I have one, actually I did 2 examples, and we're going to do 2 things. We're going to, first of all, we're going to find the scale factor. Second of all, we're going to find the point of dilation. All right, so math, M-A-T-H, has been dilated by a scale factor of, right, so remember it's going to be image measurement over original measurement. Right, and here we have nothing but vertical and horizontal lines. Right, so we can use any one we want. Let's use MA, and actually it looks like I have the coordinates down for MT and M prime T prime, so let's use those ones. All right, so remember it's got to be the image first in the numerator there. All right, so our scale factor is going to be M prime T prime divided by MT. All right, so M prime T prime, right, goes from 2 to -2, right, that is 4. MT goes from -1 to 9, right, -1 to -9, and that is 8. So that means our scale factor is 1/2. Right, and we used the measurement of the image with the corresponding measurement in the original. Point of dilation, right? So I'm actually going to change the screen so you can see the point of dilation on this one. Right? So to find the point of dilation, connect corresponding points from the image and original. The lines intersect at the point of dilation. Right? So since we know that my lines don't always I don't always have the best line, I did it in advance so that I would choose a nice skinny line and not a fat line, which can sometimes throw things off because I think it's going through the right smack dab through the point and it's not. All right, so here it is. Ta-da! All right, I chose a super skinny line. All right, so if we go from if we take a ray and it goes from the point on the original, it connects the point on the original with the point on the image, and you just keep on going, that's going to give you your point of dilation. All right, and so you just keep connecting. And if it's smaller, then it's going to go original and then image. If it were larger, then it's going to go image then original. Right? This one was closer to the point of dilation because our scale factor was less than 1, right? Between 0 and 1. Looks like in my example here I used AH and A prime H, but any one of the sides would have given you the same scale factor, 1/2. And that's all you have to do to find the point of dilation. So that point of dilation is located at a not very easy point to figure out. And I have a weekly work problem for you like this, only I made sure it was going to be a very easy point to figure out. This one is not an integer value. And there'll be one on the formative, but that one will be an integer as well, not like this one. All right. One more, and this one's in your notes, with point of dilation and how to find it. All right, so A prime, B prime, C prime is the image of ABC under dilation. Explain how you can use, and this point's not supposed to still be here. Explain how you can use a straight edge to find the center of dilation. Then use your method to draw a dot at the center of dilation. So you're just going to draw a line from the original to the image for each pair of corresponding points. All right? And I need a line, and let me try to choose, I'll just use a black line. Right, so go from the image to the original, right? So this is going to be, the original is going to be closer, right, because my image is larger. Right, and then I do the same thing with B. And oops, boy, that angle's off on B here. We'll just fix it. And also make sure you draw your lines big enough, because they eventually have to intersect. As soon as I get this one to go. It's a lot easier, by the way, with a straight edge, because you just put down the straight edge and just draw the line, as opposed to having to work your line in. All right, and let's get the last line in here between C prime and C. And you see how they all intersect in a point? Let me fix this one, though. There we go. All right, and let's make sure everybody looks good. This is the only one I think that's teensy bit off. There we go. All right, and right here is your point of dilation. So you have this one in your notes. It'll be a lot easier for you because you could just use a straight edge and just connect, right, the original and the image and the original, right? And it's going to be on the side of the, in this case, it's going to be on the side of the pre-image, because the image is larger, and so the image is going to be farther away from the point of dilation. Right? And that's all you have to do. And that's the last one. The rest of this, we're going to look at, actually, it's not quite the last part. Let me go over one last thing. And then the rest of this is going to be on the next Nearpod. Right? So the last thing I have to go over with you has to deal with point of dilation. Right? Oh, no, I'm sorry. That is for similar transformation. I am done. All right. Bye for now.